Sorry about that, guys. I just needed my calculator, but we are going to solve these 4 problems here. So first of all, looking at the sine of pi over 12. Well, one way I could approach this is, hey, I could change pi over 12 into degrees, right? So, I bet you guys remember how to do that. So, what we have is pi over 12 times 180 over pi, right? And that should give us, I'm going to use my handy dandy calculator, 12 times 180, nope, all over pi, and that gives us 15 degrees. And you can use the same thing here when finding the cosine. I'm going to convert 11 pi over 12 now. Times 180 over pi. $165 degrees. And then I'm going to convert 5 pi over 12. So 75 degrees. So this is basically saying the sine of 15 degrees, the sine of 165 degrees, the cosine of 75 degrees, and the cosine of 15 degrees. So, how I could approach this is by using these trig identities up here. So finding the sine of pi over 12, I could make that 45 minus 30 in degrees, of course, which is 15. So this really in degrees is 45 minus 30. But in radians, that is going to be pi over 4 minus pi over 3, right? So, let's calculate. So this is basically saying the sine of pi over 4, I should put that in parentheses, minus pi over 3. And we got sine, cosine, cosine, sine. So we got minus. So the minus, it goes with the minus. So what is that going to be? The sine of pi over 4 times the cosine of pi over 3 minus cosine of pi over 4 times the sine of pi over 3. So what's that going to give me? So the sine, remember, is equal to y. Sine of pi over 4 should give me the square root of 2 over 2 times the cosine of pi over 3. cosine is equal to x. Pi over 6, pi over 4, pi over 3. And the cosine is x, so that should give me 1/2. Minus cosine of pi over 4, and you know that's going to be the square root of 2 over 2. Times the sine of pi over 3, which is the square root of 3 over 2. And I've ran out of room, but that's okay. I will still put my equal sign here. So what do you have? Square root of 2 times 1, which is just the square root of 2. And you've got, wait a minute. Well, sine, cosine, cosine, sine, cosine, cosine, sine, sine. The sine of pi over 12 should be positive, though. So this is not the square root of 2 in front. That should be square root of 6 minus square root of 2 over 4. I do believe, let's check though, sine of pi over 12. Do I get the square root of 6 minus the square root of 2 over 4? Yes, I do. So the sine of pi over 12 should be the square root of 6 minus the square root of 2 all over 4. There we go. We just solved the sine of pi over 12. And the cosine of pi over 12 is about the same thing, right? But it's just a matter. I'm out of room, so I can say that this, oh, this is marker, I didn't realize that. So this is obviously going to be cosine of pi over 4 minus pi over 3. Given my trig identity, that should give me cosine of pi over 4 times the cosine of pi over 3 plus the sine of pi over 4 times the sine of pi over 3. And doing my trigonometry correctly, cosine of pi over 4 is going to be the square root of 2 over 2 times the cosine of pi over 3, which is 1/2, plus the sine of pi over 4, which is the square root of 2 over 2, sine of pi over 3, square root of 3 over 2. And that, ladies and gentlemen, is going to give me the square root of 6 plus square root of 2 all over 4. It's that simple. This is why trig identities are so fun. So our answer for the cosine of pi over 12 is going to give us square root of 6 plus square root of 2 all over 4. right? That's pretty easy. Now it gets a little bit difficult here. Let's try the sine of 11 pi over 12 now. So, we said that 11 pi over 12 converted into degrees is 165 degrees. Well, let me figure out one thing. Could it be, let's see, 120 plus 45, 165, yep. Okay, so our calculation in degrees is 120 plus 45. I got to get that into radians. So is 120 2 pi over 3 in radians? Let me see. Yep, it's 2 pi over 3. So we've got 2 pi over 3 in radians. Plus, and 45 is going to be pi over 4 in radians. And which one of the 6 trig functions are we taking of that value? The sine of that value. So we're taking the sine of that value. So this is obviously going to be the sine of 2 pi over 3 plus pi over 4. And we know our trig identity, sine, cosine, cosine, sine. So we've got sine 2 pi over 3 cosine pi over 4 plus cosine of 2 pi over 3 sine pi over 4. Okay, so sine of 2 pi over 3, remember ASTC, sine is going to be positive, so that is going to give me the positive square root of 3 over 2 times the cosine of pi over 4, easy square root of 2 over 2. Can't go wrong with that. Plus cosine of 2 pi over 3, and AS, so cosine is going to be negative, so we got minus 1/2 times sine of pi over 4, which is square root of 2 over 2. And let's see. Square root of 3 times square root of 2 will give me square root of 6. And then plus and a minus change to a minus. 1 times the square root of 2 is just the square root of 2. All over 4. But let me check my work. So what do you got? The sine of 11 pi over 12. Hey, look at that. I'm right. Okay. So, the sine of 11 pi over 12 is going to be the square root of 6 minus the square root of 2 all over 4. See, trig identities are very easy. And then you got the cosine of 5 pi over 12. Well, this is doable. I just got to figure out a calculation. 30 plus 45 in degrees, 75. Okay, that does give me degrees. So 30 plus 45 And I am running out of room again. So, let's record this. We've got 30 plus 45. And that in radians is going to be pi over 6 plus pi over 4. And we are taking the cosine of that value. So we got cosine, cosine, sine, sine. So that is going to be the cosine of pi over 6 times the cosine of pi over 4 minus the sine of pi over 6 times the sine of pi over 4. This is easy trigonometry right here. So cosine of pi over 6 is going to be the square root of 3 over 2 times the cosine of pi over 4, which I know is the square root of 2 over 2, minus the sine of pi over 6, which is 1/2, times the sine of pi over 4, which is the square root of 2 over 2. And that, ladies and gentlemen, will be square root of 3 times square root of 2, which is square root of 6, minus 1 times the square root of 2, which is the square root of 2. And that's all over 4. Easy enough. But let me check my work. What do we got? The cosine of, what was it, 5 pi over 12? Oh yeah, oh yeah. So, what do we got here? So that, as a matter of fact, gives me the square root of 6 minus the square root of 2 all over 4. That's simple. Look at that. I use trig identities just to solve these. And see, I think radians is where a lot of students get very confused, man. That's why I convert them into degrees. But you got to be careful, because if you're in like calculus class, they're going to be in radians all of the time, right? And these, ladies and gentlemen, might play a big role in calculus. And that's the video for today. Bye-bye.